Super Bowl number 41, aka LVI, is literally hours away as of the recording of this video, and sadly, this guy won't be in it. But that's okay. Tom Brady has a record 7 Super Bowl rings. And since he has just retired, what better way to pay tribute to this amazing player than to pose a math challenge? The challenge is as follows. In how many ways could Brady wear all 7 of his Super Bowl rings? For simplicity's sake, I'm just representing them as discs in 7 different colors. Here's one possible arrangement. This is just one unique way that he could wear all 7 rings. We're going to assume that he can have 0 to 7 rings on any given finger, and that the order of the rings does matter. So for instance, the red ring below the purple ring on his left index finger would be considered a different arrangement from this arrangement, in which the purple ring is now below the red ring. And similarly, the black ring on his right index finger next to the orange ring on his right middle finger would be considered different if they were reversed. Pause the video to see if you can calculate the total number of ring arrangements, and when you're ready, join me for the solution. We'll break this problem into 2 parts. We'll first consider the number of ways the 7 rings can be ordered, then we'll multiply that value by the number of unique finger positions the 7 rings can have. Let's start with the ordering. One possible ordering could look like this, another could look like this, and so on. The ordering calculation is actually pretty straightforward. This is equivalent to the number of permutations of 7 objects, taking all 7 at a time, or 7p7, which comes out to 7 factorial. Now, for any one of those 7 factorial specific ordering of rings, Tom has a certain number of ways to place them on his finger, which we could represent using these blue separators between fingers and the 7 rings, which I colored all in red since the ordering has already been accounted for. So, for this particular finger position, it would indicate that he has no ring on his left pinky, no ring on his left ring finger, and please forgive the pun, that's what your 4th ring finger is called. 2 rings on his left middle finger, 1 ring on his left index finger, 1 ring on his left thumb, no rings on his right thumb, 2 rings on his right index finger, no rings on his right middle finger, no rings on his right ring finger, and 1 ring on his right pinky. But this is actually just a combination problem in disguise. We want to find the number of ways of combining all 16 of those objects, namely the 9 blue separators plus the 7 red rings, taking them 7 at a time or 9 at a time since the 2 are equivalent. That would give us 16 choose 7 or 16 choose 9, either is correct. Now let's evaluate to see what we get. I'll first get rid of the 7p7 since we know that's 7 factorial, and I'll just use 16 choose 7. Using the combination formula, we know that 16 choose 7 is equal to 16 factorial divided by 9 factorial times 7 factorial. Now I'll cancel out the 7 factorials, and I'm left with 16 factorial over 9 factorial. That would be the same as 16 multiplied down to 9 factorial divided by 9 factorial. Let's cancel out the 9 factorials, and now we're left with this product, which is equal to 57,657,600. Wow, that's a lot of ways to show off those 7 Super Bowl rings. Let me know in the comments below if you got the same answer and if you got it using a different approach. And be sure to subscribe for a new video every 14 pi rotations of the Earth, aka weekly, featuring puzzles, problems, applications, and explorations. Thanks for watching, and see you soon.